Hello everybody, Mr. King here. I'm going to do a quick video lesson here about solving quadratic equations with the square root property. So these guided notes may help you with the work you're doing in Khan Academy right now. I hope you like the music. Just thought I'd jazz it up a little. Recording here from my studio at the top of Abbott Hall in Marblehead. Yeah, right. Okay. Seriously. So the square root property, how does it work? Well, if you have an equation where you have x squared equal to a number, you can take the square root of both sides like this. And the square root of x squared is going to give you x. Square root undoes the squaring. And the square root of 441 happens to be 21. And we have to put plus or minus here. Square root property, if we go look at it over here, if x squared is k is some number greater than 0, then when we take the square root of both sides, we get that x is equal to plus or minus the square root of k. And actually, that's a typo. Oh, no, it isn't. That's right. Never mind. Okay, so we have our answer here. X is plus or minus 21. Now, why is it minus 21 also? Well, we know 21 squared is clearly 441. You could check that out in your calculator, but we also know that when you square a negative number, it's also going to be the same 441, because a negative times a negative, we know that that's a positive. That's why there are two answers to these problems. So let's move on to the next. So this time we have 3x squared equals 243. And the first thing we want to do is we want to isolate the x squared. And so we're going to divide each side by 3, and we'll get x squared is equal to 81. 81 happens to be a perfect square, so we'll take the square root of both sides, and this is going to give us x is equal to plus or minus 9. And that's because 9 squared is 81, and negative 9 squared is also 81. As you can see, these problems are getting slightly more challenging each time, and it will go that way this whole lesson. So in number 3, we've got 3x squared minus 363 is 0. And the first thing we want to do is we want to start isolating the x squared term. So we're going to add 363 to each side. So we get 3x squared by itself. And this will give us 3x squared is equal to 363. Well, we want x squared, so we're going to divide each side by 3 now. And we divide each side by 3, we'll get x squared is equal to 121. And you're probably starting to see a pattern here. All of these problems wind up giving us x squared is equal to a number that is a perfect square. And that's by design. So we take the square root of both sides, and this is going to give us x is equal to plus or minus 11, because 11 squared is 121, and a negative 11 squared is also 121. So let's go to the next page. This one looks like it's a little more complicated. Now I have numbers on both sides here, but the goal is the same. We want to get 4x squared by itself. So we're going to add 59 to both sides. And this will give us 4x squared. And 9 and 7 is 16, carry a 1. And we've got 9 and 6 is a 5. And we've got, to carry another 1, we got 256, which is a very nice number. And when we divide each side by 4 to isolate x squared, we get that x squared is 64. Now when we take the square root of both sides, we're going to find that x is equal to plus or minus 8, because 8 squared is 64. The next one is, it's switched up a little bit here. We've got 22 minus 3x squared equals a negative 86. So we're gonna isolate the negative 3x squared first by subtracting 22 from each side. This will give us negative 3x squared is equal to negative 108. And we'll divide each side by negative 3, the number multiplying x squared. The negative 3's divide to 1, leaving us with x squared is equal to 36. 3 times 36 happens to be 108. And now when we take the square root of both sides, we're going to get x is equal to plus or minus 6. Now we introduce a fraction, numbers on both sides. The fraction's multiplying x squared. Again, we want to isolate the 1/2 x squared as our first step, so we're going to add 127 to both sides. This leaves us with 1/2 x squared is equal to 338. Now this one is starting to seem a bit strange. 338, 1/2 x squared. This seems like it might be difficult, but I'm going to show you. Lost my pen here a little bit. I can't seem to change the settings, so I'll just keep going with this. What I like to do is just multiply each side by 2/1. The reciprocal, let me write that nicer, the reciprocal of 1/2. That will give us x squared, but we got to multiply this side by 2 as well. And twice 338 is going to be 676, which is a very nice number. It happens to be a perfect square, of course. You can guess who set these problems up, I bet. X is equal to plus or minus, and the number is 26. I happen to know my perfect squares up to 30, maybe slightly beyond. That's from many years of teaching math, and so I happen to know that one. I also know that 25 squared is 625, and so if we push it out to 26 squared, well, I know that because of the 6 on the end of 26, we do a little multiply here. We see we're going to get a 6 times 6 is 36, carry the 3. 6 times 2 is 12, and 3 is 156. 2 times 26 is 52. And you can see here that my memory was right. So that's a good check. Okay, so now we come to number 7. Now we've got x squared terms on each side. So again, a little bit more complexity here. So this time we're going to push the numbers to the right again. And we're going to move the x squared terms to the left. So you may not have done this before, but this is perfectly fine to add 98 to both sides and to subtract 2x squareds from both sides. And this is going to give us 3x squared on the left. And on the right, well, this 8 and 9 is 17, so we're going to get a 7. And then, let's see, 147 here. And we're going to divide by 3 on each side. And we'll get x squared is equal to 49. And when we take the square root of both sides, we get x is plus or minus 7. Like that. Now we come to this interesting problem. This problem is a squared binomial. X minus 3 is squared equals 36. And because x minus 3 is our squared term and it's isolated, we're going to take the square root immediately. And this is going to liberate the x minus 3. It's going to get rid of that squaring. And square root of 36 is plus or minus 36. Now this problem has a little bit of a twist to it, you might say. We got to do something slightly different here. We do still need to isolate the x though, and so we're going to get x is equal to 3 plus or minus, and that was not a 36, that should have been a 6. Now, what do we do with that? Well, it turns out that what we do with that is this. We're going to get two solutions. One of the solutions, we're going to go, well, if I write 3 plus or minus 6 here, one of the solutions we're going to go over the top, and we're going to write 3 plus 6. The other one we're going to go underneath, you might say, and we're going to do 3 minus 6. 3 plus 6 is 9. There's one of our answers. And 3 minus 6 is negative 3. That's our second answer. On the next problem, the x minus 2 squared is not isolated. It's being multiplied by 3, so we have to divide by 3 on each side here. So I divide by 3 to isolate it. We get x minus 2 squared is equal to 49. Now I take the square root of both sides. And when I do that, we're going to get x minus 2 is equal to plus or minus 49. No, not 49. 7, Mr. King. Get your act together. Add 2 to each side. We get x equals 2 plus or minus 7. And you guys know what to do now. Go over the top. We get 2 plus 7, which is 9. There's a solution. Go underneath. 2 minus 7, we get negative 5. Now you might be thinking, you gotta be kidding me, this really works? Let's test it. Let's test it on this one. We haven't done this before. So take 3 as a check times x minus 2. Let's put the negative 5 in. That answer seems pretty crazy. And let's see if this is 147. We test it in the original equation. And again, the negative 5 here is what we're testing, we're checking. And let's simplify this and see what we get. Well, we go inside the parentheses, PEMDAS, and negative 5 minus 2 is negative 7. And it's still being squared, and it's still in parentheses. And we're really wondering if this is going to be a true equality. Well, the next thing we do, PEMDAS says we do the squaring of the negative 7, and that's a 49. And so that leaves us with 3 times 49, and we're wondering, does that equal 147? And in fact, it does. 3 times 50 is 150. 3 times 49 is 3 less than 150. It is 147. Check. This is a good solution. And that concludes our brief lesson on solving quadratic equations with the square root property. And I hope that's helpful to you guys when you're doing your work in Khan Academy. I'll see you soon in a Zoom, I'm sure.